I
had geometry.
I had algebra 2 third hour. I remember that because Connor was in there. He sat right in front of me.
Algebra 2 sucked because Levi would always turn.
Yeah, exactly.
What are you doing?
Oh, I was in
Okay.
class. He's throwing pencils in.
Lesson 40. That was third hour. I remember that. So.
No, that was third hour pre-calc.
No, third hour algebra 2.
Was it? I thought it was.
Pre-calc was third hour last year?
I had
No, pre-calc was second hour.
Okay, I had pre-calc.
Pre-calc was second and fifth last year. So it wasn't. Yeah. Because my algebra 2s for a while have been third, sixth, and seventh. Except this year's just third and sixth.
So maybe I had algebra 2 third hour.
Yeah, you were.
I feel like you did. Because that's my third hour is always my big class. When it's a pretty full classroom, but I have a lot of my sophomores in my third hour class usually. So I feel like Shively, I feel like you might have been different, but I can't.
I was in sixth.
You might have been. Okay. Units of the derivative, normal lines, maximums and minimums on a graphing calculator. Now, I say, we're throwing in a little bit of physics because we start talking a little bit about velocity and acceleration. There is definitely a physics connection with calculus. We hit it more later on, though. Okay, so first thing we're talking about is units of the derivative. So when we talk about derivative, you guys know it as the slope of the tangent line. Like that's what, you see slope, you've got to think derivative. So slope of the tangent line. Now, what's key to know as we go through problems is that whenever we talk about derivative, it's the rate of change of a function. Kind of like slope is rate of change. It is the rate of change of a function. And that will always help you to kind of be able to figure out maybe how to do the next step, or maybe what the units are, or just depends, I guess, on the problem. So kind of lock in your brain, units of the derivative is rate of change. As we look at example 1, you'll notice it's asking for a rate of change here. Okay. The distance s of the particle from the origin is given by this equation, s equals t squared plus 3t plus 7, where s is in meters, time is t in minutes. What is the rate of change of the distance with respect to time when time equals 4 minutes? So, if they're asking for the rate of change of the distance, what do they ask me to find? The derivative. Okay, they're asking for a derivative here. So, if I write down s is equal to t squared plus 3t plus 7. The rate of change, now it says of the distance with respect to time. Because of how they said that, of the distance with respect to time, I'm not going to just use s prime. I'm going to use the ds over dt form. Okay, because it's the derivative of the distance with respect to time. And what is the derivative of t squared plus 3t plus 7? 2t plus 3 plus 0 if you really want to go there. Unnecessary.
Am I right in saying that since time equals 4 minutes, t would equal 4? Just plug in 4.
Yep. Yeah, so then it's what is the rate of change of the distance with respect to time. So we found that. That's 2t plus 3. When time equals 4, so yes, that does mean we're plugging in 4 now. So we're finding ds dt evaluated for when t equals 4. So you'll often see that straight bar afterwards with the number after it. That's kind of evaluated at this value. So 2 times 4 plus 3 is equal to 11. 11 what? Meters per minute. Because remember, this was the rate of change of the distance with respect to time. So this is 11 meters per minute. What is this in your physics world?
I don't know. I can't
Meters per minute. So
Right.
meters per minute going one direction,
Locking
that's
her
the
brain
velocity.
somewhere.
Okay. So this is kind of a precursor of events to come. This is velocity. So they gave us a distance. How did we find the velocity? We took the what? We took the derivative. So the first derivative in calculus is equal to the velocity.
Okay.
I wonder
That's cute.
if there was a time last year when that would have applied, like when the kids are just like,
Oh, it probably would have helped us.
It would have helped us probably.
I don't know that they never really mentioned. I don't know, maybe if it helped them check at some point or not, but
I feel like
Did you
Logan
take
always
physics
talked
as
about
a
using calc.
Did you ever take a physics class?
I did.
I think you have to
Oh.
be that major.
Oh,
Good luck you didn't.
I used it. I took physics. I took physics in high school. I took physics in college. I don't know. I feel like it was an elective of some sort, or maybe I didn't necessarily have to take physics specifically, but it was one of a group of electives I could take. So I can't say that I necessarily had to take physics. I don't know. Maybe I didn't. I just don't remember. So I just remember I took it as a summer school class one summer. So I only did summer school one summer, but I did a stats class and a physics class because I needed to get them out of the way. Needed to get them out of my schedule. So okay. So first derivative, velocity. Good to know. Example 2. The velocity of a particle in meters per second is given by the quadratic equation v equals 4t squared plus 2t plus 4, where t is in seconds. What is the acceleration of the particle when t equals 3 seconds?
So is acceleration the second derivative? Please tell me it's not that easy.
It is that easy. Okay, so the connection here to be made, and I'll do kind of a side note here, is that when you start with distance, and then from distance, I think, how did I write this? You go to velocity, and velocity was the first derivative, right? And then from velocity, you go down to acceleration. And acceleration is the second derivative. If it helps, you can also think in terms of labels. Distance, a distance in this problem, what are we in, meters? A distance in this problem would be labeled in terms of meters. Well, what's velocity? Velocity is meters per second, and acceleration is meters per second squared. Okay, so that's kind of the physics connection for today. As I said, there's a lot of physics within calculus. This is far from our, this is just a small introduction. We'll definitely talk about a lot of physics and calculus. Some of you may understand the physics better than I do sometimes, just because I don't remember it always. So, we were given that v is 4t squared plus 2t plus 4. How am I going to find acceleration then? Derivative of velocity. Okay, so acceleration, when Ross says, is it really as easy as the second derivative? That's second derivative of distance, right? So first derivative is velocity. So we really already have the first derivative here, don't we? So we just need to find the second derivative. So as we're trying to find this, it's the derivative of velocity with respect to t. So I'm going to call it dv dt. And the derivative is what? 8t plus 2. They specifically want the acceleration when t equals 3 seconds. So I'm going to find dv dt evaluated at 3. So 8 times 3 plus 2, 26. If velocity is meters per second, and we did the derivative of that with respect to time, then it's meters per second squared, or meters per second. I don't like that form, but that's technically equivalent, right? And this, of course, is acceleration. Okay. Units of derivative, rate of change. Thus, velocity is a good example of a derivative. Okay, ready?
I suppose.
If we must, right? Normal lines. In math, the word, I should say word, the word normal does not mean ordinary. When we talk about an ordinary, or a normal line, excuse me, a normal line in calculus, it really means a perpendicular line. Okay? So, normal is another way for saying perpendicular. If you are asked to find the equation of the normal line, you're being asked to find the equation of the perpendicular line. I don't know if you guys can see it or not, but it should say normal there. Okay, so this goes back to using the calculus we already know, going back to some of your algebra skills and putting it all together. Find the equation of the line normal to the graph of y equals e to the x at x equals 1.
So perpendicular would like to be the same. So we need to find the slope, which would be the derivative, and then we have the opposite reciprocal, right?
Okay, so yeah. So before we get too far into this, let's review the fact that parallel lines have same slopes. Perpendicular lines have opposite reciprocals. So, the little side note I'm going to put in writing here is that perpendicular lines have opposite reciprocal slopes. That's your Algebra 1 review, right? Algebra 2 review, pre-cal review. I don't know if you saw it in your geometry year, but you saw it in Algebra 1, Algebra 2, and pre-calc. So, you got to dig it out of your brains. Okay, so where do you want to go with this?
Well, we're going to need the slope of the line.
Okay.
Would be the derivative.
Okay. So we need the slope. In order to get the slope, we need to find the derivative, yes? So our equation is y equals e to the x. It's a tough one. Can you handle it?
Mm-hmm.
What's the derivative of y equals e to the x? E to the x. Now, I'm going to write it as dy dx is equal to e to the x. What do I specifically need to know about this derivative?
The dy dx when x is 1.
Yeah, we need to find the derivative evaluated when x is 1, which means we're doing e to the first. I'm not mistaken here. Yeah, we just work with E the whole way through. I don't change it to a decimal. Okay, so now I wrote e to the first. Do I really need to write e to the first?
No, it's just.
It's just e. So what is this? This is my slope. Now officially, I guess I should point out that this is the slope of what? Slope of the tangent line, yes? What slope do we need to use? The slope of the normal line. So what is the normal slope going to be? Okay. Negative of 1 over e. I started to ask where you were getting the negative out at first. I had a brief moment of, why is he saying negative? Oh, yeah. He should be saying negative. Don't ask. As I said, I had a brief moment of, what am I doing? Okay. So our normal slope is the opposite reciprocal. So once you find that slope, reciprocal of e is 1 over e. The opposite is negative 1 over e. What else do I need to find here?
The intercept, right?
Yeah, we need a point.
Equation.
Okay. We need a point of intersection. Where is that point of intersection going to be at?
We would have to, x would equal 1, right?
Right. So we want to know when x equals 1, what does y equal? E to the 1, which is just e. So the ordered pair 1 comma e is my point of intersection. Sorry, I guess I should have warned you I have a lot of work squeezed in here. We're trying to write the equation now. Do I have everything I need? I have a point, I have a slope, yes.
Plug it in and find e, right?
Well, depends on which way you want to do this. We can plug into y equals mx plus b. I think that's what you're telling about.
I would do this.
Okay. And find, if you plug in your slope and your xy, you can find b that way. Or you can do point slope, which is what I was going to do. So I was going to do y minus y1 equals m times x minus x1. If you don't like my way, go your way and meet me in the end. Y minus e equals negative 1 over e times x minus 1. If we distribute y minus e equals, did I leave that as a coefficient? I did. Negative 1 over e times x, and then plus 1 over e. It's not pretty, but that's all right. How do I solve for y? Yeah, if it's y minus e, we're going to add e. So then y equals negative 1 over ex. And then I'm just going to write plus 1 over e plus e. I mean, the only way you can add 1 over e and plus e, I guess there's two ways. You could get decimals, or we could get a common denominator and make this one fraction, but that's not necessary. The key to know is, if I ask you, okay, what is your y-intercept? What is your b value? Your b value is 1 over e plus e. It's not just 1 over e or just e. It is whatever that value is together there. Okay. We've done stuff like this already, yes, because we've been writing the equation of the tangent line. The only step we added in is that we had to do opposite reciprocal. Okay? Flippy floppy. Whatever. I'll take it. As long as you know what you're doing. As long as you don't write flippy floppy as an explanation on a test. We're all good.
It would take every ounce of my will not to.
Not that I'd ever think you'd have to explain that, but, in case you did. Yeah. Okay. Ready to try example 4? Use a calculator as necessary to approximate. So when you see that word approximate and you can use a calculator, this means we can end up with decimals. Okay? Up here, this would have been a good one to be on a non-calculator type problem. Okay? So, we're going to approximate the equation of the line normal to the graph of y equals e to the sine x when x equals 2.7. You got all that fun information? I feel like Ethan's sitting there just processing like, oh my goodness.
Eventually.
Huh?
I said I'll get it eventually.
Use a calculator, so we're approximating the equation of the normal line. You expected that, but everyone caught that, right? Y equals e to the sine x when x equals 2.7. So where are you guys starting?
So I was going to start with the derivative, and since it's y equals e sine x, you have to do the split thing, right? Where you take like e sine x times cosine x, or is that inverse? Or is that right?
Nope, that's what you have to do. The split thing he's talking about is this is a chain rule problem. That's what my that's the official vocabulary here. So, okay, so let's look at the fact we need to find the slope, which means we need to talk about the derivative. We have y equals e to the sine x. And so when we do dy dx, the derivative of e to some power is e to that power. So e to the sine x times the derivative of that power, right? So, and the derivative of sine x is cosine x. So, let's say, you can leave it, e to the sine x times cosine x. We're not really giving our derivative as an answer here. So, what do I need to know about this derivative? When x equals 2.7. So dy dx evaluated at 2.7 means I'm doing e to the sine of 2.7 times cosine of 2.7. And this is where I have a decimal. I have a decimal with 4 place values written down. Did you guys get it? Rounded to negative 1.3862. What is that right there? Okay, so this is the slope of the tangent line. What do we need? We need the normal slope. What are your thoughts about this normal slope?
1 over that.
Yeah. So I'm going to say it's the negative of 1 over negative 1.3862. I agree it comes up positive. And we're going to have another decimal here now, right? You agree with 0.7214? Okay, so we have our slope. What else do I need? Okay, we need a point. Okay, so when x is 2.7, notice we're plugging into the original, yes? So e to the sine of 2.7, which exactly is a decimal. What'd you say it was?
I got 1.5332.
Okay, yeah. So we're going to have the ordered pair here of 2.7, comma 1.5332. And then it's writing your equation. I almost liked it better last time when it was in terms of e and I didn't have to use the decimals. Just saying. So y minus y1 equals m times x minus x1. Y minus 1.5332 equals m. I started to just write m. What is m? 0.7214 times x minus 2.7. Y minus 1.5332 equals 0.7214x minus what'd you say?
1.161.
Not what I've written down.
I got like negative 1.94778.
I have 1.9478 written down. So to multiply 0.7214 times 2.7, I have 1.9478. And then if I add my 1.5332 over, I end up with y equals 0.7214x minus 0.4146. What number did you use wrong or punch in wrong or?
I don't even know. Like, I wrote it down wrong. I don't know. Oh, okay. I used the same one.
As that one.
I used Y. Is that right?
But you're using, okay, that's okay. And you kind of skipped over what you did on your paper, so I can't. I'm like, I don't know how you got that number down, but
I don't remember writing it down.
which I get it as long as you know what you're doing. It just created the problem of going back. I don't know what you did. Okay. You guys got your calculators out and about? Example 5. Approximate the value of the relative maximum of y equals sine x on the interval from 0 to pi. So, and notice the heading does say maximums and minimums on a graphing calculator. So this is a review. Now I am going to give you a few tricks of ways to make the calculator a little bit easier, but what are we going to do here? We're going to graph. So we're going to graph y equals sine x. And I don't know how familiar you are with this, but one of your zoom options is z-trig. And for a basic trig graph, such as sine, the advantage of z-trig is it puts you, instead of numbering that x-axis 1, 2, 3, 4, 5, it numbers it by pi over 2s, I think, pi, something like that. So z-trig is always a helpful thing to use. Now, okay, so let me see, I can use my calculator or I can use Jason's calculator here. Okay, I was charging last night. Okay, what did I last graph? Who knows? So y equals sine x, whoops, sine x, z trig, which is number 7. And as I said, the nice thing is you will notice that it's going through nice neat intervals, right? And that makes it a little bit easier to see there. Now, specifically, what did it ask us for?
The max between 0 and pi.
0 and pi. So here's my other suggestion, is that you go into your window setting, and this one's not too hard, but if it was a harder interval, if you go into your window setting, we only need to be looking at this graph from 0 to pi. So I would make my x min 0, my x max pi, which keep in mind, it changed as soon as I entered off of it. I just hit pi for the pi. I didn't type all those numbers in. And then when you graph it, since we have it as just 0 to pi, the good news is I just have to look on this interval and find the max. I don't have to try and distinguish what we're looking for here. And you guys know how to find your max, right?
I think I know what it is before you do the calculator.
True. True. This is one that you should know what this max is before you do it on the calculator. Now, does that give you what you expected to give you, though?
Well, I assume that value is pi over 2.
Okay, exactly. And that was going to be my, what is 1.57? That is the value pi over 2. So, let's see. Some keys I was going to write down. First of all, one thing I did do is I did change my window. I set my window. Oops. I set my x min and x max. And I set those at 0 and pi. And that's because that's what they gave me, right? Officially, in order to do this, I used my second calc max to get there, right? And when I do second calc max, it says the max is at 1.5708, comma 1, which the discussion was, what do we assume 1.5708 is? Pi over 2. They're not going to tell us pi over 2, but that's just a good one to know. It really is. Now, the question is, approximate the value of the relative maximum. What is my maximum value here? 1. Okay, so value of relative max, realize, is 1. I know in pre-cal, a lot of times I'd write the ordered pair for a min or a max, yes? Realize, if they want to know where is the maximum happening, so where is the max? That's your x value, pi over 2. What is your max? 1. What is the value of the max? Max is the y value. Okay, so as I said, I know I wrote lots of extra stuff there, but just some things to help. Estimate the minimum of y equals x cubed plus 4x squared minus 7x minus 5 over the interval 0 to 4. I'm going to graph it, right? After I graph it, what would be helpful? I would change my window to 0 to 4. I would also get out of Z-trig. So go back and do like the standard zoom, and go from there. So I'm going to write the information down while you work on it. We're going to graph y equals x cubed plus 4x squared minus 7x minus 5. I'm going to change, and it's not that you have to as long as you're paying attention, my window x min and x max to 0 and 4. And then, of course, I'm going to use second calc minimum. I don't know, do I even need to do this? Is it going okay for you guys? Notice I just went ahead and did zoom 6. Notice there's a lot going on in this graph, right? We're only being asked about the interval 0 to 4, so I'm going to change my window to 0 to 4. And I'm going to regraph it. And what are we being asked to find? A minimum, yes? If they wanted a max, I'd have to do some investigation as to what happens up above, right? I'd have to change my y max and figure out what's going on up there. What do you guys get for your minimum?
I got 0.6943 and then negative 7.5.
I agree. So what is my relative minimum value? Yep. Negative 7.5972. So maybe at least Z-trig was helpful. I know this page was a lot of review here, right? But I think Z-trig was kind of an aha. Huh?
This is a good lesson to have on Friday. It's not that bad.
I think the worst thing about this lesson is probably the normal line. But it's just because there's multiple steps. I feel like there's lots of work.
Just review.
It is very much review. I mean, it's what you've been doing since Algebra 1 if you really want to get technical, you know. You just didn't do it with derivatives at the time. So, okay.